Okay, alaikum everyone. Um can someone confirm if they can hear me?
Yes, sir.
Okay, thank you. So we are going to start a couple of announcements. Some students have sent me a message, and I think they have asked the TAs as well that where the lecture videos are available. The lecture videos are available on Zoom Cloud. We will also create a YouTube channel because on Zoom Cloud there is a limited duration you can store the videos. In fact, the duration is not limited; the space is limited. So after several lectures, we'll have to recycle that. Um, so so these videos will be available on YouTube. We'll create a YouTube channel. For now, they are available on Zoom Cloud, and the link for the Zoom Cloud videos, they are available on the Piazza website. The class has a class management website hosted on Piazza, and the link for Piazza is on LMS. So if you go to LMS, if you are registered for the course, and if you go to LMS, you will see that on the main page of LMS, you have several links. One for the lecture videos using which you have joined this session, and also you will see my office hours. There is a link for Zoom link for that as well, and also there is a Piazza link, which is the course management website. I would strongly suggest that you should use the Piazza website as much as possible for asking questions, and we will allow student groups to work with each other to complete the homeworks and discuss with each other while completing the homeworks. Submit maybe one single homework. So coordination with the students can also be done using the Piazza website. You can search for partners and teammates who can work with you on the homework. So Piazza website is the one which we will use for mostly for course management. um, the material for the class will of course be available on LMS in the resources section, and on the main page of LMS you will see a link to Piazza. If you have not joined it, please go ahead and join it whenever you get a chance. And the lecture videos, they will be available, the links for those will be available on Piazza, and they will be hosted on Zoom Cloud. There will be a passcode to access each lecture video. Make sure that you note that passcode, or copy paste it or something like that, so that you can access the previous videos. Um, with that, I think we are going to go ahead and start the content, from where we have left off last time. Meanwhile, if there are any logistic related questions, I will be happy to answer those. And yeah, feel free to ask those now. Are there any logistic related questions? No. Okay, great. Um, so what we are going to do is we are going to start from where we have left off last time. So basically, we talked about the internet infrastructure. Um, you know, all the links and switches which connect all the devices which are connected to the internet. And the job of the internet is to make sure that every device which is connected to the internet, whether it is through wireless, whether it is through 3G, 4G, 5G, or whether it is through an Ethernet cable, whether it is through a coaxial cable, whether it is through a DSL line at home, whether it is through an optical fiber going into a data center, all the devices on the internet, they are able to communicate with each other, just like our desktop clients, our mobile clients for Zoom. They are talking to each other right now, and we are using those to communicate with each other. In fact, it's the job of these applications, which transport the data, my audio data, to you, and your pictures, etc., to this side. And the communication is supported by these applications. The job of the network is to make sure that you have some sort of a connectivity ensured between any two devices on the internet. And remember, we have billions of devices on the internet at the moment. Any device with an IP address should be able to talk to any other device with a different IP address. Okay? And the IP addresses are the names that we use on the internet, are really the addresses that we use on the internet for the devices to talk to each other. So if device A wants to talk to device B, they need to use their IP address in order to send data to each other, in order to send these packets or chunks of data to each other, which is just packet is nothing more than a sequence of bits. It's just a sequence of bits, maybe 8,000 bits. You know, that's a typical example. Typical packet size is 1,000 bytes, which is 8,000 bits. You can send that packet from one point to another point. So if I'm sending a file to you, I will divide my large file into smaller chunks of data, which we call the packets, and these packets will be sent to you from my side, one after the other. Each of these packets will travel independently. Okay. So far so good. Any question at the moment? No? All right. So I'm going to share the screen now, and we will start off with slide set 2. Oh, by the way, these slide sets will also be available on LMS. I'm not sure if we have uploaded those or the TAs have uploaded these as yet, but we will make all of these slide sets available to you, and they will be uploaded on LMS. LMS will also be the place where all the homeworks and assignments, programming exercises, they will be uploaded. Okay. So so I'm going to just go ahead and share my screen. So can anyone confirm if you can see the screen? Maybe you can type in the chat window, or you can use the non-verbal, yeah, non-verbal. Yes, you will see a symbols at the list of participants. If you click on the participants, you will see a sequence of symbols there: go slower, go faster, no, yes, etc. So you can see that. Okay. So so somebody has sent a private message. I think while I'm teaching the class, we will not have time. I will not have. I just happened to look at that, but we will not be able to look at the private messages which are sent over the Zoom messaging. So I will not be able to answer those. Since I have seen this question, so I will answer that. But maybe I will not be able to see while I'm teaching. I will not be able to see that question again, or somebody else is asking the question. So if you have to ask a question, you can raise your hand, and um, either you can raise your hand, or you can just since the number of students is small in this class, you can just speak up. Although I would I would like to you to raise your hand first, and then send the question. So the question is, the packets coming from one source will use one path to reach the destination, and the answer is maybe. If nothing changes on the internet, all the packets which go from one source to one destination, one device to another device on the internet, they will take precisely the same path. Why? Because these packets are routed based on the IP addresses which are written inside the packets. It's very important to realize that these packets include the data within the packet, includes a header, and that header area includes the IP address of the destination. So this packet, as it goes from one link to the next link, one link to the switch, so that it can be forwarded to the next link, the switch will examine the destination IP address and decide on the basis of that destination IP address, where do I need to send this packet? Okay. So if the destination address does not change, all the packets belonging to that destination address or destined for that destination IP address, they will be sent. The same action will be taken by all the switches in between, and they will be sent along the same paths. However, it is very important to realize that internet structure can be changing dynamically. Links being added all over the internet, links being removed, links going down, links being congested, etc. So in that case, it is possible that within a session, from the same source to the same destination, within a session, some packets will take one path, some other packets might take a different path. That is possible. If that answers your question. Okay, so so what we are going to do today is just a very quick review of the last time. What is network made of? We talked about it last time, that the network is made up of a sequence of links which are connected with each other through switches, and there can be several switches and links which are connecting any two devices on the internet. So between myself and a machine in the US, maybe in New York, there can be many switches in between, and we gave lots of example of switches. One Wi-Fi switch here in my office, then a rack switch in the SSE building, and then another one in the IST building, in the library building. Then many switches in PTCL network, many switches in Singapore Telecom network, many switches in AT&T's network, until you reach your destination. Okay, so between any source and destination, you can have a variable number of links and switches. It is also possible that two devices which are talking to each other, they are directly connected to each other. So you can have a piece of wire connecting the two network cards of two computers which are just sitting next to each other. That is perfectly all right, valid way of connecting these two devices. And that's just one link between these two devices. You can also have a single switch, a single Wi-Fi switch, and two devices connected to that Wi-Fi switch, and they're talking to each other. So that means they will be talking to each other through that switch. So data or packets from one device will be going through to that wireless device, which is somewhere on the roof, and then will come back to the other device. Okay. We also have networks which are called ad hoc networks, in which you don't have these central infrastructure, no switches. So devices directly connected to each other, and you can imagine that those kind of ad hoc networks are really ad hoc. You cannot have global scale ad hoc networks. You can only have very small scale ad hoc networks, which means that few devices in a room, they are talking to each other, directly connected to each other. Every device is talking to each other. You don't need a switch in that case. However, again, as I said, the size of that is going to be very small, very small. Any questions so far? So no question. Okay, if there are no question, then what do we do to make best use of this network, which is made up of switches and links? One thing that we talked about the internet is that the internet is a shared resource. These switches and links, they are shared resources. Okay, and how are these shared? We will talk about that in the course. So to answer the question, what does it take to deliver a web page to your browser? We talked about it last time. So you type a web address in your web browser, in this case, www.bbc.co.uk, and then you hit enter, and then behind the scenes, your browser will make a network connection, will send a request to a server which belongs to bbc.co.uk, hosted somewhere else in the world, and that server will respond with a file, and that file will be displayed by your browser. In order to accomplish this, what you need is an addressing system, as we talked about. So this addressing system is absolutely necessary. without this, your browser will not be able to reach the bbc.co.uk. Okay, and also we need a naming system. So what is the difference between the naming system and addressing system? As we explained, the addresses are the IP addresses, 32-bit numbers, which are assigned to every device on the internet. Okay, remembering those numbers is not easy. The computers, they will talk to each other by using those numbers, but as a human, it would be very difficult for me to remember 10.32.76.99, which is a sequence of 8 bits, 8 bits, 8 bits, and 8 bits. So you might have seen IP addresses in this dotted decimal notation. So 192 dot something something something. So 4 octets you will see, 4 sequence of 8 bits, which is 32 bits. So those are IP addresses, but humans will not be able to remember those. So humans will be able to remember the names, bbc.co.uk or cnn.com or lms.lums.edu.pk, or youtube.com. So that naming system is something which gives you this human readability. And obviously, there is a way to translate those human readable names to these IP addresses. And that system which translate these human readable names to IP addresses is called the DNS system, domain name system, domain name service, or domain name system. The way that we use DNS all the time, by the way, but we don't know it. When we type a web address or an HTTP link in the web browser, so in this case, for example, www.bbc.co.uk, then behind the scenes, your browser will make a DNS request to some DNS server and will get the translation, from the DNS server for www.bbc.co.uk, translated into an equivalent IP address, Okay. Now, once the IP, so this is all done behind the scenes. Once that IP address is known to you, is available to the browser, then the browser will make a network connection to that machine which has that specific IP address, and that machine actually is the server where the bbc.co.uk web pages are hosted. Okay. And then we also have these building links, which are Ethernet, fiber, wireless, cable TV, all of those links, and these links are connected back to back with each other using these packet switches. These packet switches, they connect these links with each other. And these packet switches, as we explained through many examples in the last 2 lectures and today as well, that many these switches are available in a hierarchical fashion. So we have several switches in LUMS, in this room, in this building, in this floor, in the IST building, and then in LUMS network, and then in PTCL, and so on and so forth. So it's important to realize that there is a hierarchy. There is a hierarchy of these switches, which takes the packets from the source to the destination in a hierarchical fashion. Okay. So now moving on. Now let's take a look at the internet infrastructure. This is a very simple example where 3 switches are connected to each other, and you have devices which are also connected to these switches. And these green circles here, these big green circles here, they represent sort of ISPs. And these ISPs could be a university network as well. So for example, all of these guys here, this blue guy here and this blue guy here, these can be devices on LUMS network, and this green guy here could be the LUMS ISP. Okay. And this is one switch which is shown on LUMS network. In fact, in reality, there will be many switches within a university network. So for example, LUMS will have of the order of about 100 switches scattered throughout the campus. Okay. So so now understanding what the structure of the internet looks like, how it is shared, how do we share the structure. And to explain how it is shared, I will use the example of the plain old telephone system, POTS system, plain old telephone system, which is the landline telephone, which many people still have in their networks. Some people don't have, they just rely on mobile phones. But many people still have this landline coming into their houses. I will draw a comparison between the internet, which is very different from the telephone network. The way that sharing happens on the telephone network is very different from the way that sharing happens on the internet. In the internet, the data is transmitted between the two devices, source and destination, in the form of packets. In the form of packets. So you have packets being communicated between any two devices on the internet. However, in the case of phone network, in the case of telephone network, you don't have packets. You have a complete path available to you between the two devices, and this complete physical path is available to you. You can use that physical path to send analog data, to send your audio in the form of electrical pulses or optical pulses, or you can send that to send your audio in the case of in the form of digitized voice. But still it would be a complete path, physical path available to you. We will explain that a little bit more as we progress today. Okay, so so if we consider this example internet infrastructure that we have been considering, the two devices who want to talk to each other, this guy on the left, upper left here, and this guy on the bottom right here, these guys want to talk to each other. These guys have a path along which the packets will flow. Now, it is important to realize that this path is given to these two guys to communicate with each other one packet at a time, one packet at a time. When these two guys are not communicating with each other, that path is free and is available for somebody else to use, okay? Not in the case of phone network. In the case of phone network, once the path is given to a pair of users who want to talk to each other, then the path belongs to them. Nobody else can use that path. Okay. Now, how does the sharing happen in this case? So we are showing here three connections: this purple one, this blue one, and this green one, between different pairs of source destination. Okay, between different source destination pairs. But you might notice that this switch here and this link here and this switch here, these are the shared resources. All the packets for the green communication, all the packets for the blue communications, all the packets for the purple communication are passing through this central link and are passing through these two switches that we have connecting these two ISPs. Okay, so this is how the sharing is happening. The sharing is happening between the communication channels. Okay, now, so these shared links and switch resources, these are the core part of the internet, in the sense that internet really relies upon a heavy duty sharing between these connections, communications. Okay, now, what are the main approaches of sharing of network resources? One of the main way that you can categorize those is reservation based, which is used in the telephone system, landline telephone system, or it could be on demand, okay, which is used in the case of internet. Okay, the reservation based, in the case of telephone network, this could be with or without multiplexing. We don't know multiplexing, but we can probably make a guess about it. Okay, multiplexing perhaps means that you are doing some sort of sharing, but this sharing is very different. And I will explain what that means. The reservation, the sharing which is used on the internet is on demand, let's just take a look at how are these two implemented, how these two different approaches implemented. So one approach is reservation based, used in telephone system, landline telephone system. The other approach is on demand. The other approach is on demand, used for the internet. Now the reservation is with or without multiplexing, and I will explain that. So in the case of telephone system, landline telephone system, the reservation based approach is also called a circuit switching approach. Circuit switching approach. Okay, so you create a circuit all the way from source to destination. Create a circuit all the way from source to destination. While for the internet, the reservation, there is no reservation. You have on demand delivery. You have on demand delivery, and this is done through what we call a packet switching mechanism. It uses a packet switching mechanism, and these packets travel over the internet, which is an example of a packet switched network. Packet switched network. Okay, so how do we implement these? Let's take a look. So first, let's take a look at the packet switching. In this case, the packets are treated on demand. So for example, one source and destination, they want to communicate with each other. They have lots and lots of packets going in either direction of communication. And these packets are treated as they are available, as they are available. So for example, if I'm sending file from A to B, then this file is divided into smaller chunks, which are called packets. Maybe I will send some packets, then I will stop for some reason, and then maybe I will send some more packets. I will have pauses between this sending of these packets. So I'll send some packets, will pause, will send some more packets, will pause, will send some more packets. Okay. As the packets arrive, as the packets are ready to be sent, they are treated on demand. They are sent on demand. The network resources are not available, not reserved to you until you have a packet to send. जब भी packet भेजना होगा, then the network resources will be made available to you. Okay, and in the case of packet switching, the control of packet, how the packets are admitted to the network, how the packets are sent over the network, how they are admitted to the network, that we call admission control. This is per packet admission control. What that means is that these packets are sent on a per packet basis. So the admission control is packet by packet. Admission control is packet by packet. You admit a packet into the network and then send it along. You have one more packet to send, you admit that packet again and send it along. If you don't have a packet, the network is free. Somebody else can use it. Okay. So you admit the packets on a packet by packet basis. In the case of circuit switching, however, in contrast, in the case of circuit switching, the resources are reserved per active connection. So once again, recall that we said that circuit switching is used for the telephone network, the landline telephone network, where you have a connection. Once a connection is established between these two telephone lines, this connection stays there. Whether you use that connection or not, whether you talk or not, if you stay quiet, no matter if you stay quiet, you will still be billed for the duration of the connection that you have established. Okay. And in this case, you admit the data, you admit the information into the network, you admit the information into the telephone network on a per connection basis, So I want to create a connection, telephone connection with another number in Lahore, in Karachi, in Islamabad, outside Pakistan. I will have an admission control. My connection request will be admitted by the telephone network. Okay. So per connection versus per packet. Very important to understand that. I will pause here for a second to answer if there are any questions.
सर सर
Yes.
ये जो पैकेट स्विचिंग है और नेटवर्क सर्किट स्विचिंग है सर, इसमें हम पैकेट स्विचिंग में हमने आर्किटेक्चर प्रिंसिपल्स पढ़े थे। उसमें ये था कि जो पैकेट स्विचिंग है यानी कि इंटरनेट का जो आर्किटेक्चर है वो एक बेस्ट एफर्ट सर्विस प्रोवाइड करता है। तो ये
जी।
जो सर्किट सर ये भी वैसा है या ये एक पर कनेक्शन दे रहा है, तो ये मतलब एक किस्म से प्रॉमिस कर रहा है कि ये यानी कि आपकी जो कनेक्शन ये यानी कि इस्टेब्लिश करेगा, जो भी आपने कम्युनिकेशन करनी है वो हर हाल में पहुँचाएगा।
जी, good question. So, packet switching network is a provides a service which is a best effort service. It is possible that network will be congested, and some of the switches in the middle of the network, they will not be able to handle the rate at which packets are coming. So they will process lots of packets, but they will probably miss some of the packets. Those packets will get dropped. They will not reach the destination. They will get dropped because they could not be processed by a switch in the middle. There can be many other reasons the packet can get dropped. There can be reasons that packet can get corrupted, means some of the bits in the packets can be flipped, which means that it will become useless for us. Okay, so in that case, we call that this is a best effort service. Not so in the case of circuit switching. In the circuit switching, it is guaranteed delivery. It is guaranteed delivery, not just guaranteed delivery, but also guaranteed that I will be able to send your information over this circuit switched connection in a specific period of time. You can also guarantee the time. In the case of packet switching network, even if the packet gets through, even if the packet reaches the destination, you cannot guarantee that when will it reach the destination. It can suffer some delay along the network, and we'll talk about delay towards the end of today's lecture, or maybe early part of next lecture. So in the case of packet switching network, its best effort. In the case of circuit switching network, it will be guaranteed delivery. Of course, it is important to clarify that in the case of telephone network, if one telephone exchange comes down, if one telephone exchange comes down, you still cannot guarantee anything. But that means the complete connection is gone. You are just not able to make any connection in that case. Okay. However, in the case of packet switching, even if all the switches are working, all the links are working, you can still have packet drops. That's why it's called best effort service, and circuit switching is guaranteed service. Okay. There is a hybrid of these as well, and the hybrid of these is called a virtual circuit network. Normally, what happens is, all the internet or packet data networks, which all the ISPs provides. The internet is a packet data network. So all the ISPs, Cybernet, Supernet, Nayatel, PTCL, WorldCall, all of these in Pakistan, they provide a network infrastructure. Okay, you can connect to them. So if you go to PTCL, ask for a network connection, they will probably bring a cable to your house or an optical fiber to your house. In the case of Nayatel, I think they provide optical cable to the house in Islamabad. Not sure about Lahore, but they will provide some sort of connectivity to your house, and then you get service from their network. Similarly, if you have Jazz 4G type of connection or Mobilink 4G Chargy devices, these are also the devices which provide connectivity to their network wirelessly without the line coming into your physical line coming into your house. So once you get the service from the ISP, these ISPs, they provide end connectivity to you. However, it is often the case that these ISPs, they establish virtual circuits over very frequent routes. So for example, if there is a route between Lahore and Multan, route between Lahore and Islamabad, these ISPs, they will create virtual circuits. They will create virtual circuits. An example of a virtual circuit, and some of you might have heard the name MPLS, multi-protocol level switching. It's an example of a virtual circuit. But virtual circuit really means that you have a packet network, which means on a network, the packets are treated hop by hop. At every switch, the packets get forwarded from the source to the destination. At every switch, the switch opens up the packet, looks at the destination address, and sends it to the next outgoing link. And it reaches the next switch. The next switch does the same, opens up the packet, looks at the destination IP address, and sends it to some direction to the next switch. And the next switch will do the same and same and same until the packet reaches the destination. What these ISPs do to create these virtual circuits is that instead of wasting this time of opening up the packet and looking at the destination address, what they do is that they mark the packets. They mark the packets. Maybe, think about it as you color the packet as red or color the packet as blue. I'm just using that example. You don't color the packets, of course. It's a sequence of bits. How do you color the bits? So what these ISPs do is that if a packet originates from Lahore and is destined for Multan, so what they do is that instead of opening the packet at every hop, at every switch between Lahore and Multan, there can be many of these. So usme to time waste hoga, right? Instead of wasting the time opening up the packet, looking at the destination address at each of the switch and making the decision, where do I need to send this packet to? What you do is that you just mark the packet or color the packet with blue. And the switches, when they see the color blue, they don't look at the inside of the packet. They don't open up the packet. So avoid that slow processing, and then boom, fast path and blue packet, immediately send it towards Multan. They already know that. Okay. For that, they obviously need to set up some internal tables, and we'll talk about the tables as we progress in the course. Maybe chapter 4, we'll have some more discussion on that. Okay. So very, very important to understand this concept of packet switching and circuit switching. Okay. So good so far, so good. Okay, great. So in the case of circuit switching, all the way from source to destination, the source will send a reservation request to the destination. Okay. And this reservation request has to travel through the network. So this source here is sending a request to establish a circuit for the entire connection, not for packets, for the entire duration of communication, to establish a circuit with the destination. So the source will send a reservation request to the destination. This reservation request will reach the destination by going through these switches. Along the way, this switch will look at the request, and the request might specify that I need 10 megabit per second of connection. That means I want to establish a connection with the destination, and on that connection, I will be sending data at a rate of 10 megabits per second. Okay. If the switch has room to accommodate, the switch will oblige. Okay. And it will progress from one switch to the next switch and the next switch to the next switch until it reaches the destination. And if everyone okays the connection, then this connection is established all the way from source to destination. This green connection all the way from source to destination is established. Okay. So these switches along the way from source to destination, what they have done is they have established a circuit. This is a circuit switched connection. And once it is established, the source is ready to start sending the data. The source will be able to send the data all the way to the destination on this circuit. Nobody else can use the resources allocated for this circuit. Okay, no sharing per se. So once the source is done, the source will need to send a tear down message that I'm done. I want to de-establish this circuit. I want to disconnect this circuit. Okay. And this request will also travel this path, and destination will disconnect. All the switches along the way, they will disconnect. There has to be some protocol, some mechanism which has to be implemented along the way. Okay. So in the case of circuit switching, if we look at the micro picture within a switch, You have many incoming connections. We are only showing 2 incoming connections, but a switch can have hundreds of ports, even thousands of ports. No? So a switch, we are showing only 4 ports here, 4 interfaces here, and source is connected to one interface, destination is connected through one interface, maybe not directly, maybe through another switch. Okay. So when the request comes to this switch to establish a connection to the destination, this switch will establish a circuit like this. वो अंदर mark कर लेगा अपने पास. This would be a sort of a semi-permanent connection which is made between this point in the switch and this point in the switch, and a circuit is now established between the source and destination. In this example, in this figure, we are only showing one switch here, but you can have multiple switches from all the way from source to destination. Okay, so now, so as we said that circuit switching is used in the case of telephone network. So there is a pair of wire which is coming inside your house to which you connect your landline telephone set. Okay, from your landline telephone set, your audio in the form of electrical signal travels over that pair of wire and goes to a nearby local office, which is maybe 1 to 2 kilometers, 3 kilometers, maybe 4 kilometers within your house. Okay, so your audio signals will reach the local office, by traveling on that pair of wires. Nobody else can use that pair of wire. That pair of wire is between your telephone set and local office. It's completely 100% dedicated to you. So no sharing of that resource. Now I will explain that in the case of circuit switching, normally you don't do sharing of resources, but think about the situation. A local office can cater to 20,000 subscribers, 20,000 customers. So all of these guys have their phone lines coming into the local office. These 20,000 physical lines coming into the local office. No big deal. Okay. But now, this local office, which is nearby your house, is connected to many other local offices in the city. And those local offices are all interconnected with each other. And those local offices are also connected to maybe intercity exchange. In the case of Lahore, that could be on Edgerton Road. So there's a big telephone exchange on Edgerton Road. Similarly, the reason that we have this intercity exchange, everyone needs to be connected to this intercity exchange, is everyone should be able to call from Lahore to outside the city. City ke bahar call karni hoti hai, so you have to have some sort of a physical connectivity to go outside the city, and that would be through the Edgerton Road exchange, for example. And this Edgerton Road exchange will be connected to exchanges in all the major cities in Pakistan, and those major cities will be connected to all the nearby smaller cities. Lahore will be connected to Kasur. Lahore will be connected to other smaller cities, Shadra and other places which are in the vicinity of Lahore. So complex interconnected network of telephone network as well. It's also very, very highly interconnected. But you still have circuits on that. Okay. Now, the thing that we wanted to point out is that, let's say, on a local exchange in your vicinity, let's say you live in DHA Lahore nearby Lums, and you are connected to this DHA telephone exchange, which is on Ghazi Road, about a couple of kilometers from Lums. The pair of wire is going from your house and all the other 20,000 subscribers that it is serving into the local office. But now this guy is connected to many different local exchanges, also connected to Edgerton Road exchange. And, mind you, you also have to be able to call outside Pakistan. So you have to have some international gateway exchanges in larger cities, which can connect you to exchanges outside Pakistan as well. Otherwise, you will not be able to make a call from within Pakistan to somebody outside Pakistan. So you have to have some sort of, exchange connectivity outside Pakistan as well. Now, the point is once you reach your local exchange, which is in DHA Lahore, that exchange is connected to many other exchanges. Do you want these 20,000 lines? These 20,000 lines going from this local exchange to all the other local exchanges which this local exchange is connected to. Why? Because you want to, you want to be able to call to somebody in Lahore, you want to be able to call to anyone in Lahore in any location. You want to be able to call to anyone in Islamabad at any location, anyone in the world at any location. So you have to have that physical connectivity to everywhere. So, but you are only connected to your local exchange. That means your local exchange is responsible for providing further connectivity. If it provides connectivity by using this one piece of wire which is going to your house and one piece of wire to all the other local exchanges that it is connected to, that is going to be a nightmare. For 20,000 customers, you are doing that. 20,000 pieces of wires, long wires going from one local exchange to many different other local exchanges and intercity exchanges and maybe an international exchange here as well. So that's a nightmare. That's a nightmare. How many pieces of wire will be coming into all the local exchanges? So you don't do that. You don't do that. In this case, what you rely on is called multiplexing. It's called multiplexing. Now, internet also does sharing. Internet also does sharing for the packet switch network. You also have sharing for the packet switch network. You also have multiplexing for the packet switch network. Multiplexing means many to one. So that means you have one resource and it is used by multiple people. However, the multiplexing that you use in the case of internet is called statistical multiplexing. Statistical multiplexing, which means that if you don't have to use the resource is completely available. But in the case of circuit switches, the kind of multiplexing that you use in the case of circuit switches is not statistical. It's deterministic multiplexing. It's deterministic multiplexing or simple just multiplexing. Okay. So the multiplexing that you use in the case of circuit switched networks, the benefit of that is a piece of wire going from one local exchange to other local exchange. Normally, it can carry one piece of audio, just like the piece of wire from your telephone set to your local office just carries your local audio. This piece of wire is specifically is dedicated to your house, is going from your house to this local exchange, only carries your audio. Okay. However, I can't have lots and lots, 20,000 or 40,000 pieces of wires running between my local exchange and all the other local exchanges. 40,000 here, 40,000 here, 40,000 here. No, that would be a nightmare. So what normally people do is that they say that we will have a link which can carry many audio conversations simultaneously, And the way it is done is, many different ways. There are two very famous ways are by using multiplexing in the time domain or multiplexing in the frequency domain. So in the case of time domain multiplexing, what you do is that you divide the time into slots. And in this case, what I'm showing here is a set of 1, 2, 3, 4, 5, and 6 slots. Red, dark yellow, light yellow, green, blue, and then this dark purple or magenta, whatever color is that. And that gets repeated. You have red again, dark yellow again. So this is a repetition here. So what you have done here is you have divided the time into pieces of chunks, time chunks, which we call time slots. Okay. So in the red time slot, remember we have time along this axis, time along the horizontal axis. So in the red time slot, one conversation, one audio signal will be transmitted. In the second time slot, this dark yellow audio signal will be transmitted. Then this one, then the green one, then the blue one, and then this magenta one. I'm just calling it magenta. I don't know whether it is magenta or not. Maybe it is. But so these 6 conversations happening simultaneously using one piece of wire, which can handle these 6 conversations, these six conversations simultaneously. When I say simultaneously means you can use one piece of wire to carry these 6 conversations. But internally, what is happening is this piece of wire is giving little pieces of time to each conversation. So some time given to the red conversation, then to yellow, then to yellow, then to green, then to blue, then to magenta. Okay, and then the turn of red again. Okay, and this is done so fast. This is done so fast that between this red and this red, between these two reds, it happens so fast that you don't realize that there is a breakage in the voice. Your audio signal just goes through. No, this is magic. So this is called time division multiplexing. Time division multiplexing. Now you might be surprised. You might be surprised that you can have optical fibers. You generally have optical fibers running between exchanges and telephone exchanges. Remember, we are still talking about circuit switching. We are still talking about telephone exchanges. You have optical fibers running between these telephone exchanges, and these telephone exchanges can carry conversations, audio conversations on these optical fibers. One single optical fibers can carry thousands and thousands and hundreds of thousands of audio conversations. Magic. One piece of wire normally would carry one audio, just like from your house, the piece of wire going to local exchange will carry only your audio conversation. But these really high bandwidth optical fibers can carry simultaneously lots and lots and lots of conversations, lots and lots of conversations. Okay. Somebody had raised a hand, so please go ahead and ask the question.
Ji sir, Assalamualaikum.
Walaikum salam.
So I just wanted to ask regarding the time slots wali cheese. Is the time slot time this factor also the reason why lagging occurs while a communication is occurring?
So this will not be the reason. You will not be able to notice the lag because of this time slot delays. So this red and the first red and the next red, there is a time difference between the two, but this will be could be in microseconds. You will not be able to realize it. You will not be able to perceive it. So the delays that you hear are not because of this. The delays that you hear are because generally, if you are talking about the delays on the internet, for example, when you are making a WhatsApp call, that is all our packet switch network. That delay is because the packet gets delayed. The packet which contains your digitized audio gets delayed in going from source to destination. Okay, these time slots, they do not cause the delay which is human perceivable. Does that answer your question?
Yes, sir. Thank you.
Okay, great. So now what we do is that in each of these time slots, in each of the time slots which get repeated after so often. So in this case, I'm only giving example of six time slots which get repeated. But in reality, you can have hundreds of thousands of these time slots get repeated and done so quickly, in of the order of microseconds, or maybe even smaller than that. It happens so quickly that you will not realize that your turn has gone and come back again, and you will just send the audio signal within the time slot which is allocated to you. So for each conversation, for each circuit, per circuit, I will allocate a single colored time slot. So red may be allocated to one circuit, green to another circuit, blue to another circuit. So we'll have separate time slots allocated to one circuit. So one particular circuit will be using this red time slot, and this red will be repeated after every 6 time slots, and all the reds will belong to that one circuit. If I'm not talking, I will not have any audio signal. These red time slots, they will be vacant. During these time durations, during these time slots, very small time slots, I will not have any audio information to send. I will not have any signal to send because I'm not talking. But still, I'm being billed for it. I'm being billed for it. Why? because I have made a reservation. Remember, the circuit switching is reservation based. I have reserved the red slot for myself. Whether I use it or not, I will need to pay for it. Nobody else can use it. Does that make sense to everyone? No, maybe, yes. So we have this yes and no. You can probably use those. Yeah, makes sense to some people, a few people. Others are either not listening or maybe sleeping or. Yeah. Great. Makes sense to lots of people. Okay, I'm going to clear that now and move forward. So now, so we learned about time division multiplexing, and this is done in the case of circuit switching. So we do have circuit switching. But we can still do sharing. This is sharing, but this sharing is very constrained kind of sharing. This is not quite sharing. I mean, in the sense that you have divided the physical resource into 6 time slot, but 1 time slot is yours. If you don't use the red time slot, nobody else can use it. So it's not sharing in the true sense. It's not sharing in the true sense. Although you have shared the resource between these 6 guys, but these 6 conversations, you cannot hold more than 6 conversations here. You cannot hold more than 6 conversations. So, Aisha, you have a question?
Yes, sir. Sir, I wanted to know that in time division multiplexing, is there a criteria to select the duration of the time slots? Or
yeah, so good question. Is there a criteria to select the duration of the time slot? So one thing is obvious, that if you have just one user, if you have just one time slot which gets repeated, which means no 2 users are sharing this resource, so it's only red. So that means the duration of the time slot can be anything because it's all yours. Okay, but what should be the duration of the time slot? I would like this first opportunity for red here and the second opportunity for red here to be very close to each other. And when I say very close to each other, that means that my ear should not be able to perceive that there has been a breakage. And this should be very, very fast. This should be very, very fast. So this depends upon what is the kind of signal that you are trying to send. So audio signal, frequency ranges from 0 to 4 kilohertz. So if you repeat the red time slot twice of that rate, then you are good. Your ear will not be able to perceive something has broken. You will not be able to make any losses. So so some people who may have taken the signals and systems course, they might realize that we were talking about the Nyquist sampling here. But really, if you don't know about it, that's also okay. What is important to realize is that these 2 red guys, these 2 red opportunities should be very, very close to each other. And this depends upon what is the pitch of what is the frequency, maximum frequency of your audio. Of course, if it's the human audio, the maximum frequency is about 4 kilohertz. If it's fine music, Mozart or something like that, then it could be 10, 12 kilohertz. In which case you have to have these red guys to be even closer to each other. So now, what would be the duration of one of the red guys? Well, again, it depends upon how many guys you want to accommodate. If you want to accommodate 6 guys, so first of all, you will determine that how frequently do I need to repeat the red guy. So maybe between these 2 red guys, I need to have 1 millisecond. I'm just giving an example. In 1 millisecond, I need to accommodate how many users? Let's say you want to accommodate 6 users, as in this example, then 1 by 6 millisecond would be the duration of the red time slot. If you want to accommodate 100 users, then 1 by 100 millisecond would be the duration of each time slot. Okay. Is that clear? Does that make sense?
yes, sir. Yes, sir.
Okay, that's great. So now, time division multiplexing is just one way of sharing the physical resource among the users. But again, realize that this is not true sharing. Once red is allocated to me, it is allocated to me forever until the duration of the call. Okay, I will be billed for that. Nobody else can use that red time slot, which means that if I'm using this kind of a multiplexing mechanism, the example that we have given, we will not be able to support more than 6 conversations. We will not be able to support more than 6 conversations because we have only 6 time slots which get repeated. Okay. If this were a packet switching network, you will still have slots in which you will transmit the packets. You will still have slots in which you will transmit the packets, but those slots will be freely available to everyone. Available to everyone, which means you can accommodate as many users as you want, Okay. Of course, if these users are sending lots and lots of data, they can cause congestion. In the circuit switch network, even with multiplexing, you cannot have congestion. Okay. Now, the other way that you can share the physical resource, a piece of wire, between the different users is frequency division multiplexing. What you can do in this case is every guy will transmit for the entire duration of the time, will be communicating. So in the time division multiplexing, you take turns. So my turn, then your turn, then your turn, then your turn. So 6 people will take the turns and then they will repeat. In the case of frequency division multiplexing, what they will do is that they will decide on a specific frequency band in which they will transmit for the entire duration of time. Turns नहीं लेंगे आप पूरे time के लिए transmit ही करते रहेंगे, but only for a limited set of frequencies, only using a limited set of frequencies. Okay, so this leads to what we call frequency division multiplexing, because each guy is only allowed to transmit in a specific frequency band. Now, you might say that the audio signal is 0 to 4 kilohertz. They have to transmit the 0 to 4 kilohertz. So, what if you allocate different frequency bands? How they are going to communicate the audio? Well, they will need to translate their audio to these different frequency bands, and there are various mechanisms to do that. Again, a topic which probably covered in signal and systems. If somebody has taken that, if you haven't taken the signals course, that's perfectly all right. Just understand that you will be using a band of frequencies to transmit your audio. Somebody else will be using a different band of frequency to transmit their audio, and you can transmit those simultaneously without interfering with each other. एक single piece of wire के ऊपर, on a single piece of wire, you can communicate all of these signals, 6 signals simultaneously, if they are using non-overlapping frequency bands. Okay. So once again, one frequency band per circuit. एक पूरा का पूरा frequency band आपका होगा. Whether you speak or not, that is yours. You will be billed for that for the entire duration of the call. Nobody can share in frequency division multiplexing. Okay. Now, we use these sort of timing diagrams very often in the networking course, and these timing diagrams, they show these devices who want to communicate with each other, and very, very important to realize the vertical axis in these diagrams. The vertical axis is time. Which means that if this computer on the left, if this guy on the left wants to send data to this computer on the right through a sequence of links and switches, okay. Now, once I send the data from this guy, this data will not be immediately available from the source. The data will be available not immediately. It will take some time for the electrical signal or the optical signal or the wireless signal, to propagate. We gave an example of signal sending from Lahore to Karachi and it coming back. In that time, you can perform a lot of cycles on your CPU. So you, in the same way, it will take some time to send the signal originating from the source S and moving towards destination and going through these switches. I will show this example here. Very important to realize that this blue line here This blue line here is slanted line, So this guy on the left, this guy source on the left injects some bit onto the line. This link इसके ऊपर कुछ इंजेक्ट करते हैं. वो ऐसा नहीं है कि वो बिट जो है जब आपने यहाँ पे डाली एकदम से वो ब्लू वाली साइड पे नहीं चलेगी. It will travel maybe slightly less than the speed of light as an electromagnetic wave, and then after some time it will reach the first switch. So realize that this line is not horizontal. This blue line, which is showing the propagation of the signal, is not horizontal. It is slightly slanted. It is slanted down on the right, which means that it will take some time. Once again, remember that we have time on the vertical axis, so it will take some time for the electrical signal to propagate on this link. Now this switch here, the first switch here in the middle, will process that whatever data it will receive, whatever signal it will receive, and that signal will be transmitted to the next guy and then to the next guy. So you see that it will take some amount of time. It will take some amount of time for the signal to propagate all the way from source to destination. Maybe this source wants to establish a circuit with the destination, and it is only sending a circuit establishment request. Maybe it's telling the first switch that, hey, I want 5 megabit per second to establish a connection with that destination. That switch will talk to the next switch, and then the next switch, and so on and so forth until it reaches the destination. And then a confirmation will come. A confirmation will come back, and the circuit will be established. The circuit will be established. Remember, this is circuit switching. You have to reserve all the links and switch resources all the way from source to destination, all the way from left to right. Okay, so this circuit establishment process will take some amount of time. ये टाइम इसको लगेगा कुछ ना, ये टाइम लगा और ये वेस्ट हुआ. ठीक है, इस टाइम में आप डेटा भेज सकते थे, but without establishing the circuit, you cannot send data on a circuit switched connection. Packet switch में भेज सकते हैं. Packet switch में you don't need to establish a circuit because each packet is on its own. You just send the packet. Within the packet, you write the destination, and the switches will open the packet, look at the destination IP address, and will decide where to send the packet. No need to establish a circuit in the case of packet switch network, in the case of internet. But in the case of telephone network, you have to establish the circuit. Once you establish the circuit, you can send the data. And you can see that this data is flowing. Again, this line here is a bit slanted. ये थोड़ी सी slanted है. Once again, why it is slanted? Because the signal that you inject on the left, it will take certain time to propagate to the right. कितनी slanting होगी? कितनी ज़्यादा slanting होगी? Well, depends upon how far those stations are. If they are too far, if they are on another satellite, they might take a very long time to reach. The signal might take a very long time to reach that other satellite. Okay, so very important to realize, understand this timing diagram from left to right. Okay, and then you send this data, chunk of data. Now, this light purple, data that we are showing here, two things which are important. One is the slanting line that we have here. This tells you that the signal that you send from the left, how long will it take to reach to the right? Okay, that delay is called as propagation delay, and this delay is dependent upon the speed at which the signal is propagating. That delay also depends upon how far these other machines are. If this machine is in the same city, it will reach quickly. If it is in a different country, it will take more time. If it's on a different planet, it will take even more time. On a different galaxy, it might take light years to reach there. Okay, but on the left, also realize that if I have lots of data to send, I will just keep on sending these data in the form of signals. On the left, यहाँ से भेजते जाएंगे, हमें पता नहीं दूसरी साइड पे पहुंचा या नहीं पहुंचा. So I will quickly be done in this amount of time. ये भी एक amount of time है. On the left, what I am showing here is also the amount of time this amount of time is called the transmission delay. Is called the transmission delay. कि आपको data inject करने में into the pipe, into the circuit, data inject करने में कितना time लगा है. This is called transmission delay. So this transmission delay does not depend upon where the destination is, does not depend upon how fast the speed of light is, does not depend upon how fast the signal propagates. Even if you are sending the data to a different galaxy, you can very quickly be done by sending the data, by injecting the data. You don't know when it will reach there, maybe in some years, in some light years, but you are done here by injecting the data into the pipe. Okay, आपने यहाँ से तो inject कर दिया है, कब वहाँ पे पहुँचेगा कोई पता नहीं है, ठीक है? So how fast can you inject the data into the pipe? That is defined by the speed or bandwidth at which this link is operating. We use the term bandwidth here, but bandwidth is not the precise word for this. Signal system, जिन लोगों ने अगर लिया है किसी background है, they will realize that bandwidth is not this, you know. But in this course, we use the term bandwidth and speed of the link interchangeably. So it really depends upon how fast that link is operating. So remember, when we get internet connections from our ISPs, we say that give us a 1 megabit per second connection or give us a 10 megabit per second connection. What that really means is that this link is operating at 10 megabit per second, which means you can inject 10 megabit of data in 1 second. If it is a 1 gigabit per second, that means you can inject 1 gigabits in 1 second. That does not mean कि दूसरे एंड पे पहुंचने में कितना टाइम लग जाएगा, ठीक है? दूसरे एंड पे हो सकता है कि if it's another country, it might take a very long time to reach there. If it's in the same city, it might take a different amount of time to reach there. Okay, so very important to realize the difference from this figure. This dimension, vertical dimension, यहाँ पे जो ये delay है on the left hand side, this is called the transmission delay, and the delay that you inject the signal and that signal appears on the other side is called the propagation delay. ठीक है? An example of this could be a water pipe. Water pipe के अंदर आप पानी inject करते हैं. If the pipe has a very large diameter, you can inject the water at a very high rate. बहुत high rate पे inject कर सकते हैं उसके अंदर ना. So that's equivalent to the bandwidth. That 10 megabit per second, 1 megabit per second, 1 gigabit per second. So water pipe की जो diameter है, ठीक है? Length of the water pipe is equivalent to your propagation delay. So एक water molecule जो आपने यहाँ से एक end से फेंका है, उसको दूसरे end पे पहुँचने में कितना time लग जाएगा? That really depends upon the flow of water, जो speed of signal propagation, approximately the speed of light, and the length of the pipe. कितनी दूर है वो pipe ना? So एक molecule को उतना time लग जाएगा दूसरे end पे जाने के लिए. But how fast can you inject water into the pipe does not depend upon कि pipe कितना लंबा है. इस बात पे तो नहीं वो depend करता कि pipe कितना लंबा है, ठीक है? So this propagation delay and transmission delay, does this make sense? Yeah. Okay, now once you are done sending the data, you will also need to tear down the circuit. Okay, and when you tear it down the circuit, this is using a similar kind of protocol जो हमने circuit establishment के लिए इस्तेमाल किया था. Okay? Now there are some problems here. I will just mention quickly the problems in 2 minutes and then we will finish. So one of the problems with this is that you can have wasted utilization. That means if you have data to send for some period of time and you are silent for a long period of time, in this silent period, you know, the connection is yours. You are billed for that. फिर आपने थोड़ा सा data भेजा और फिर जो है खामोश हो गए. And then you send some data and then you are quiet for some time. In these quiet times, you are actually wasting the resources. We call this wasted utilization. Out of this entire duration of time, you are only sending useful data. ये जो मैंने यहाँ पे लेफ्ट पे सर्कल बना दिए हैं इसके अंदर, इतनी देर के लिए आप यूजफुल डेटा भेज रहे हैं, बाकी कुछ टाइम आपने वेस्ट कर दिया सर्किट एस्टैब्लिशमेंट में, कुछ वेस्ट कर दिया सर्किट टीयर डाउन में, एंड देन देयर इज अ लॉट ऑफ टाइम व्हिच इज वेस्टेड waiting for data to be sent. When you are idle, you don't have anything to send. Okay, so wasted utilization. And the other thing that is important to realize here is, in the case that if you have very small amount of data to send, very small amount of data to send, you establish a connection, you send that data, and then you tear down the connection. So data भेजने में इतना time नहीं लगा जितना connection establish करने के अंदर time लग गया. So you have this huge overhead of time, Remember, vertical axis we have time. So you have huge overhead of time on the left side for establishing the connection and for tearing down the connection. The amount of time that you are sending the useful data is actually very, very small. Okay. So in the case of circuit switching, you establish a connection all the way from source to destination. What if something fails? If something fails, then bad luck. The connection is gone. There is no going around. If this was a packet switched network like internet, तो packet by packet जाते, अगर ये चीज fail हो जाती तो packet दूसरे रास्ते से चले जाते. But not in this case. The green circuit here has to be torn down. It will automatically be torn down, and then you will need to establish a new blue circuit. ये नया establish करना पड़ेगा. Again, उसके लिए वही time waste करना पड़ेगा. So establish a connection and then send the data. Okay. So circuit switching does not route around the troubles. So we'll finish here, and if there are any questions, I will answer that. And next time we will just quickly recap circuit switching, packet switching, and all the types of delays that I talked about, and some more delays as well. Okay. कोई question है तो पूछ लीजिए. Any questions so far? No hand raises? Oh, okay. We have some questions, so people are typing. Why don't you just ask the question, typing. Hafiz Muhammad Uwais, what is the question?
अस्सलाम वालेकुम सर.
जी
सर अगर हमने एक पैकेज है हमारे पास है, हमने उसको भेजा, उसकी डेस्टिनेशन एड्रेस एक है सर, एक और अगर स्विच है या एंड पॉइंट है सर, वो अपना जो मैनिपुलेट कर लेते हैं अपना एड्रेस, तो सर वो पैकेज की क्या होगा, उसके पास चला जाएगा?
पैकेट उसके पास नहीं, अगर वो कर लेता है. सो एक चीज इसके अंदर हम भूल रहे हैं कि ये जो दरमियान में स्विचेस हैं, इन स्विचेस के पास जब पैकेट जाता है तो उन पैकेट्स ने उनको खोलना होता है और उसके बाद डिसाइड करना होता है कि इसको कहाँ जाना चाहिए. उनके पास टेबल्स होती हैं. अभी हमें पता नहीं है वो टेबल कैसे बनते हैं, लेकिन बिहाइंड द सीन्स जो है ना, कोई मैजिक चल रहा है जिससे वो टेबल्स बनते हैं. वो मैजिक हमें पता चल जाएगा चैप्टर 3-4 में जाके, जो है ना, वो पता चलेगा हमें वो टेबल्स बनते हैं. तो उस टेबल को वो कंसल्ट करेंगे और उन्हें पता चल जाएगा इस पैकेट को जो है ना इंटरफेस नंबर 372 पे भेज देना है. बहुत सारे इंटरफेसेस हैं, वहाँ पे भेज देना है. अगर कोई डेस्टिनेशन अपना आईपी एड्रेस चेंज कर लेता है तो वो अपना आईपी एड्रेस तो चेंज कर लेगा, लेकिन वो उन टेबल्स को चेंज नहीं कर पाएगा. उन टेबल्स को चेंज करेंगे तो फिर बात बनेगी. सो इफ यू कैन चेंज द टेबल्स, then you can cause problem. And this is something that PTCL did with YouTube about 10-12 years ago. उन्होंने YouTube की सारी ट्रैफिक जो है वो पाकिस्तान बुला ली. So we'll talk about that in more detail as we progress, but for now it suffices to say कि खाली अपना आईपी एड्रेस बदलने से जो है ना वो काम नहीं चलेगा, किसी और की ट्रैफिक आपके पास नहीं आएगी. जो दरमियान में स्विचेस हैं उनके अंदर भी जो है आपको कुछ गड़बड़ करनी पड़ेगी. ठीक है. साद आजम, आई थिंक यू आल्सो हैव अ क्वेश्चन.
यस सर. तो मैं पूछ रहा था कि अगर मेरे पास एक डिवाइस काफ़ी सारी डिवाइसेस को आगे डाटा सेंड कर रही है, तो एक कोई बहुत ह्यूज टाइम स्लॉट आगे डिवाइड होगी जाके, या मल्टीपल टाइम स्लॉट्स पहले ही रिजर्व कर लूँगा मैं?
हाँ. सो इफ यू आर डूइंग ए मल्टी पार्टी, इंटरनेट के ऊपर जो हम बहुत सारी कनेक्शंस हैं ना, जैसे फॉर एग्जांपल वी आर रनिंग दिस जूम सेशन वेयर देयर आर 20 पार्टिसिपेंट्स, 20-25 पार्टिसिपेंट्स. तो इस केस में तो ये पैकेट स्विच नेटवर्क है. सर्किट स्विच नेटवर्क के अंदर जो है You will need to establish 2 circuits. If you want to do a 3-party call, then you will need to establish 2 circuits. Actually, everyone will need to establish 2 circuits. See? So two different time slots will be allocated. For each circuit, you will have a time slot allocated. So 2 different time slots will be allocated if you are talking to 2 people simultaneously. Okay? But that's only for the case of circuit switch network. जिसके ऊपर मल्टी पार्टी 2 से ज़्यादा होती नहीं है. Generally, it's not done. You can have 200 people attending a webinar on Zoom, but that only happens on the case of internet. इंटरनेट के केस के अंदर जो है ना, थिंग्स वर्क डिफरेंटली. यू डोंट हैव डेडिकेटेड टाइम स्लॉट्स. तो इस तरह से टाइम स्लॉट्स नहीं है. वहाँ पे ये होगा कि एक पैकेट will replicate itself and will reach 100 different participants or 200 different participants. So my audio which is being packetized, this packet is going to all the participants. जो अभी जितने भी students यहाँ पे ज्वाइन किया हुआ है, जिन्होंने Zoom के सेशन को, उन सबको वो वाला पैकेट जा रहा है. one copy each. किस तरह से जा रहा है, वो टाइम स्लॉट्स उसकी एलोकेटेड नहीं है. पैकेट्स जो हैं वो फ्री फ्लो करते हैं. टाइम स्लॉट्स उसके लिए हम एलोकेट नहीं करते हैं. एंड वी विल टॉक अबाउट दैट इन द नेक्स्ट लेक्चर एज वेल. एक एग्जांपल हम उसके लिए.
ओके.
Any other question?
Sir, is the transmission delay dependent on the speed of the internet?
Transmission delay is exactly dependent upon the speed of the link that you are connected to. जिस लिंक के साथ आप कनेक्टेड हैं सिर्फ उसके ऊपर डिपेंड करता है और बाकी लिंक्स की नहीं. सो फॉर एग्जांपल, इफ you from your house you are connected to PTCL using a 10 megabit per second link, so that link has a speed of 10 megabit per second. लेकिन let's say कि आप अमेरिका में किसी सर्वर से कनेक्टेड हैं, CNN.com के, वो 10 megabit per second पे नहीं होगा, वो शायद 10 gigabit per second के ऊपर कनेक्टेड होगा. So 10 gigabit per second के ऊपर कनेक्टेड होगा, that does not mean कि आपकी जो है वो स्पीड 10 gigabit per second हो गई है. You are still, at max you can inject the data on your link at 10 megabits in 1 second. उससे ज़्यादा नहीं इंजेक्ट कर सकते. So ये हर लिंक की जो स्पीड होती है वो डिफरेंट होती है. सेम भी हो सकती है ऑब्वियसली. लिंक की जो स्पीड होती है, जिस स्पीड पे लिंक ऑपरेट कर रहा है, वो लिंक आपको जो है डिक्टेट करता है कि उसमें डेटा कितनी स्पीड पे इंजेक्ट कर सकती हैं, कितने रेट पे आप उसमें से एक्सट्रैक्ट कर सकते हैं. सो अगर 10 megabit per second का लिंक है, 10 megabit per second in 1 second can be injected, 10 megabit per second in 1 second can be extracted out of that. ठीक है?
Right, sir.
So any other question? No question. Great. So Tariq has something to say.
We will clear this up, that what is speed and bandwidth, and these words are used interchangeably, but this is basically the perception that the user has when he downloads a file, kitni jaldi file download hoti hai, and that is slightly different from this propagation delay and is related to the bandwidth. लेकिन ये हम clear up करेंगे, we'll clear this up with examples.
जी जी, बहुत काफी एग्जांपल आएंगे, होमवर्क आएंगे, परेशान ना हो, घबराना नहीं है आपने. ठीक है जी. So I am going to end the session. Thank you very much. खुदा हाफिज.